So what are mutually exclusive events?
They cannot occur at the same time.
Right.
They have
They're
no outcomes in common.
right, exactly. So there are two things that can't happen at the same time. You can't have an event where it rains and it doesn't rain in the same place at the same time. It's either raining or not, right?
Okay.
One of the examples that I talked about from the previous videos is if you have a single die, right? And you roll that single die, the number that you get is either going to be even or it's going to be odd, right? It's not going to be both at the same time. Okay, so a number is either even or odd, not both together. Those are mutually exclusive events.
So what should I put for number one?
Well, you just told me. So you're going to say that mutually, so here, let's straight. So you can say mutually exclusive events are events that cannot occur at the same time, right? That's what you told me. That's what they are. Now, for example, okay, an example of mutually exclusive events is, now you can think of your own example. What example can you think of where the outcomes are in separate sets with each other?
Let me go to if they have no outcomes.
Well, then that would be impossible. But what I'm saying is, let's say we talked about one die. Here's a sample space for one die, remember? Give me an example of mutually exclusive events from here. How could I create two sets that didn't have any outcomes in common?
Even or odd?
Yeah. So I could say an example of mutually exclusive events is rolling a single die. Whoops, let me not, hold on, I don't know why it did that weird like that. Rolling a single die and getting an even number and an odd number on the same roll. You can't get an even number and an odd number on the same at the same time, right? We're gonna see some examples, don't worry. We're gonna see more examples of this when we continue this. So this was question one, okay? This was question. Now, let's go and look at the second question here. Here we're asked to classify, determine whether the events are mutually exclusive. So we're talking about rolling a die. So we're rolling a single die, get an even number, okay, and a number less than 3. Are these mutually exclusive or not? Well, so here's how we look at it. We say, are these mutually exclusive? Well, if I think about, if you're not sure what this means, then make the sets. Okay, so question 2. Question 2. Are these events mutually exclusive? Whoops. Mutually exclusive. Well, let's see. Okay, it says, A says, rolling a die. So you're rolling a single die, and it says that we want to find out if it's getting an even number and a number less than 3. So what we want to do here is we want to think about rolling a die. So the first event is getting an even number, okay? And the second event is getting a number less than 3. So if you're not sure about this, you can list the outcomes that would fall into each one. So if we want to get an even number from a single die, what outcomes would that be?
2.
2 and 4 and 6, right?
Yeah.
Those are even. Now, okay, then which numbers are less than 3? Well, those are
1.
1, 2, and 3, right? Now, if this is the part that sometimes is confusing for people, okay? Now, the question you ask yourself here is, do these sets overlap? They do. They overlap here. They overlap at 2, right? If they overlap, so the question is, do the sets overlap? Okay. Do the sets overlap? In other words, do they have common elements, right? They do. They overlap at 2. Now, if the sets overlap, then they are not, then the events are not mutually exclusive.
So no.
So this would be no, right? Because mutually exclusive means, think of exclusive clubs. They're hard to get in, right? So they're not mutually exclusive. So this event would be no. So A would be, we would answer no. So here, in part A, we would say not mutually exclusive. You can just write no, but I want to be clear for the sake
I
of,
just put no, the sets overlap.
I'm sorry,
I put no, the sets overlap.
that were,
Okay.
they're not mutually, that's fine. So they're not mutually exclusive. That's the only little bit of terminology that sometimes messes students up. If they're mutually exclusive, they should be totally separate from each other. Okay, let's look at B and see what B says. Hold on, let me cursor come back to me. There we go. So B is asking us to roll a die. And it says, get a prime number. And here she helps you out. The prime numbers are 2, 3, and 5. And get an odd number. Okay, get a prime number and get an odd. Do those sets overlap or not?
I mean, yeah.
Yeah, they overlap. So that would mean they're not mutually exclusive, right? B is not mutually exclusive either, because odd numbers are odd numbers are 1, 3, and 5. Right?
You stop sharing.
Oops, my apologies.
That's fine.
So here, this is, how about now? Does that make sense?
Yeah.
Okay, so here we have, this is, I'm looking for annotate the screen. So this is, we have, this is get an odd. So our odds are 1, 3, and 5, right? And we have some overlap. It doesn't matter, by the way, how many overlap. Any number, as long as you have at least one overlap, they're not mutually exclusive. So B again would be no. So A and B are both no at this point. Now, how about C? Roll a die, get a number greater than 3 and a number less than 3. What do you think about that?
Yes.
Those would be mutually exclusive, correct? So C should be yes. And how about letter D? Select a student in your class. The student has blonde hair and the student has blue eyes. Is this possible that these characteristics would overlap in somebody?
I don't get it.
Okay, we don't know about the characteristics of the students, right? But what this is asking is, would it be possible to select someone who had blonde hair and blue eyes?
That wouldn't make sense. So no.
You've never seen somebody with blonde hair and blue eyes?
Yes, I have.
That is possible, right? So remember, because they can overlap, they're not mutually exclusive. Okay? Mutually exclusive means they don't occur at the same time. So you can have a person who's blonde hair and blue eyed. So the answer to D would be no, they're not mutually exclusive events. Okay.
All right.
They're not mutually exclusive. Okay. All right. Now we get into actually computing the probabilities. And this, the majority of this section, and there will be a video later. They fixed our internet again, my house. So there will be more uploads to follow. Probably everything should hopefully be uploaded by 3 o'clock today, if not sooner. But the table below represents the college degrees awarded in a recent academic year by gender. So let me scroll up so we can at least read this. Whenever you have a table like this, most of, a lot of these problems, not all of them, but a lot of these problems have tables in them. And some of them have the totals for you, some of them don't. This one doesn't have the totals. So before you start doing the probabilities, you need to work out the totals. the row totals that go across and the column totals that go down. So you want to work out the row totals and the column totals here. Okay. So you're just gonna add them up. So like, let me write this down. This is 573079. And then we have 211,381, and then we have 24,341. Okay, and then we have 775,424, 301,264, and 21,683. 683. Okay, so here, what we're gonna do is we're gonna choose, I'm gonna start, see if I can share. I think I have B. I do have it. So when you work this out, if you add 573,079 plus 200, the comma's in the wrong place, 211,381 and 24,341, you get 808,801. Okay. And if you add 775,424 plus 301,264 plus 21,683, you get 1,098,371. Okay. Now, if you add up those two totals that you see on the right, 808,801 plus 1,098,371, you get 1,907,172. Okay. You can add the column totals yourself and compare the answers that you see on the screen. And then once you get that, then we can start looking at the probabilities of different things. Okay. Any questions about the totals at all so far?
No, I got it.
Hmm?
Just I'm writing down number A.
Okay. So here we want the people with bachelor's degrees. So sometimes people have a little bit of a difficult time knowing what to read on these charts, but so always take a minute and look at it is my advice. So the bachelor's category is this first column and it goes down. So the people with a bachelor's degree is going to be this number, 1,348,503. And we're going to divide that by the total number of people in the sample. Well, the total number of people in the sample is 1,907,172. So if you take those two numbers, you put them in your calculator. Let me 1,348,503, and I'm going to divide it by 1,907,172. So here, let me show you just to remind you how that works. So if I do the calculator, which I don't have up here, let me open it. Okay, stop sharing for a second while I bring up the calculator. Then what I can do, share the screen. What I can do here is I can say, now that I've got those totals, I can say, all right, well, there's $1,348,503. And I can divide that by 1,907,172. So you just put the number of people in the category over the total at this point. And let's see, we have this 0.707. Remember, this would round to 1 because this 0.6. If I want to set my decimal places, you can go to mode and set your decimal places on 4 if you choose. And then I can go back, grab this answer here. And there's my decimal, okay? And to get my percent, I just multiply by 100. Now the next part of this question, so let me multiply by 100 here. And this is 70. Oops, I must have forgotten to set it. Oh no, it is on 4. Why did you not? I wonder why it didn't continue. Let me see. All right, there it is. Okay, so there's my number. 7071. 70.71 is what that comes out to be. So now I can go on to B here. B is asking me for the likelihood of a doctorate or a degree that's been awarded to a woman. Okay. Now that's where this gets tricky. Okay. If we look at the doctorates, how many doctorates do I have?
$46,000.
Right. 24.
24.
Right? There's all my doctorates, right? Where are all my degrees awarded to women?
Like the bottom.
It's
in the middle.
This third row here, right?
Mm-hmm.
This is my women, right? Now, what happens is we have an overlap, don't we? So these are not mutually exclusive, are they?
No.
Because here, and that's what we want to be careful of, because here we're going to end up double counting these 21,683 women. Okay. And so what we have to do is we have here, I'll write it on the screen. This, what we're actually doing here is we're looking at the probability of having a doctorate plus the probability of being awarded to a woman minus the probability of both together. So this is the probability of a woman or a doctorate, a doctorate and a woman. That's essentially what we're happening here. And so we're taking away this piece. Let me put it on the screen. So the probability of having a doctorate is 46,024 over the total, which is the purple number, 1,907,172, right? Plus the probability that you're a woman, which is 1,098,371, divided again by the total. And then we're subtracting 21,678. Those are the people that we counted twice. When you do all that arithmetic that you see here, you should get on the top 1,122,712 over 1,907,172. Any questions about that part?
Hold on. I'm still writing it down.
Take it. Any questions about that?
How did you have to subtract it?
Okay, because you said that there's an overlapping category, right?
Mm-hmm.
So when I count, let me remove the drawing here. When I count the people who have doctorates, so I count these people here. I count this group and I count this group, right? As part of this number here, right?
Mm-hmm.
Then when I count the women, I count this one, and this one. Did I count one of those groups twice?
No.
Watch
I mean,
again.
yeah.
Watch again. So I count this group here. These are, so there's 24,341 men who get doctorates, is what this chart said. There's 21,683 people who are women who get doctorates. And this is my total. So this total comes out from these two. Now, when I count the women, I count this. Now there are 775,424 women who have bachelor's degrees. There are 301,264 men who have, women who have master's degrees. But there are only 21,683 women who have doctorates. I counted this 21,683 as part of this total at the bottom and as part of this total over here. Okay, I only want to count these people once. So I add up both of those totals and then I subtract this overlapping category. Anytime you have an overlapping category, we want to count them one time and one time only.
Mm-hmm.
Okay.
Also, I think I got the thing wrong because I'm looking at the answer key and B says 0.589.
Okay, let's add it up and see what's going on with that. So, but A was okay.
Yeah, just one number off.
A
So
was
like there's
okay.
no one in that one.
All right, so let's see here. 46, so we have 46,000. I'll do it on the calculator right now. 46,024 plus 1,098,000 371 minus 21,683, and we're dividing it by 1,907,172. Okay. And we're supposed to get 5887. All right, let's take a look. Let's do the math and see what we end up with. So here we're going to clear this out. Not that I have to, it makes things a little nicer. Let me clear that and clear this. And move this out of the way. Okay, oops. Let me move this out of the way here. Okay. Now I can turn that down and press key. All right, so we have 46,024 plus 1,098,371 plus or minus. Now, did you put this all in at once or did you get this answer on top first?
I got it.
You got, okay, so now you take this answer. We have 21,683. And that gives us this, okay? Gives us 112,217 or 1,000,000, I'm sorry, 1,122,712. And we divide that by 109. Oh, sorry, 190, my mistake. 190,7172. There it is. Okay. If you happen to put this whole thing in and then divide it, you have to make sure that you put parentheses around the numerator. Because otherwise it'll just divide the last number you put in by whatever the denominator is.
Oh yeah, that, and I also switched the mode. I switched it to 3 decimals,
Oh,
and it
okay.
got the correct answer.
Oh, that's okay. Either way, but as long as you understand what you did. Are we good with this one now?
Yeah.
Are you sure?
Yeah.
Okay. All right, let's go to part C. Part C of the question says, okay, we kind of answered this without answering it. A doctorate awarded to a woman. So we're looking at just the women and just the doctorates, right? So here's my doctorates awarded to women right here in this cell right there. Now out of the total, okay. So 21,683 out of the total number that are awarded. Okay. Any questions on letter C for that?
Oh, I see it.
How about D, not a master's?
I'm pretty sure what we have to do is we have to add all the total of bachelors and doctorates.
Right, add
excluding the
those.
masters.
Yeah, so you just add the bachelor and the doctorates together and put it over the total, which is your purple number. Very good. So not so hard, but that mutually exclusive event on B, that's the one that's tricky. But as long as you understand the charts, and I think you understand how to read them for the most part, as long as you understand how to read them, you should be, you should do fairly well with this part. We're going to see more of this kind of thing in 4.3 when we get to conditional probabilities and other kinds of things that we see. So this will be another skill that we practice on. Okay.
Mm-hmm.
All righty. So let me scroll up for the sake of the video here. There we go. Not a master's degree, when you do the math, should come out to 0.7312. Got it correct. Let me clear the drawing. Okay, are we good with this one?
Mm-hmm. Yes.
All right. All right, so now let's take a walk back to the homework here. And whoops, wrong screen share. I said that, but then where is it? There it is. Okay. All right. Now, this one is pretty similar, but the numbers are a little more friendly. So the following doctors were observed on staff at a local hospital. Before you do the probabilities, go ahead and get the totals. Okay. Go ahead and get the totals. So MDs and osteo. And we're looking at pathology, pediatrics, and orthopedics. So we have 6, 7, and 20. That's 32. And we have 1, 2, and 2. That gives us that number. So this is 30. What is that? 31.
The sum of the MD is 33.
33, right? And then how about the osteo people,
It's 5.
right? So this, let me point out something here, because this is another one of those cross-checking kind of things that comes in really handy. When you go to do your, this is 7, this is 9, and this is, well, these are big, aren't they? I might, you know what I'm gonna do? I'm gonna do this on the whiteboard in a minute. I'm gonna draw this here, but I'm gonna make it because I want to show you something about this. Always when you do these tables, this is problem. You always have the option of checking your arithmetic. So here, let's do this one so I can show you, because this will be good for the next couple of problems that we do. When you have your, and I guess I should fix the bottom, shouldn't I? Because that was kind of bad. All right, let's do this like this. There's the bottom there, and the bottom going across here. That's better. That looks more believable. Okay, so we have this. Now, do some columns here. This is my not straight line. Okay. So you have your MD here. I'll put in my text boxes. This is my MD. This is my osteo. And this is my total. And then this is going to be my pathology. my pediatrics. And my orthopedics, and I need another line. That's all right. Orthopedics. Okay, let me just make another bar down here for my totals. When you do this, because I actually, when I did this on my paper, while I was doing it with you, I missed a number and I misadded. So here, let me show you here. This is 6.
Mm-hmm.
This is 6. This is 6. This is 1. And obviously that's 7. So they're giving us a break on our arithmetic. This is 7, 2, and 9. And I'm going to drag it over just a tad there and up a bit. There we go. And then this is going to give us 20. And this one I'm going to have to drag down, and I'm 22. Obviously, that's 22. So this is going to be 33, as you said. This is 5. And this is 38. So one way to check this is this corner total, the total of all of your subjects, all of your participants in your sample space should be the same. The row totals should match the column totals. So 7 plus 9 plus 22 should be 38. And 33 plus 5 should be 38. Okay, so just always make sure if you're doing, because we're going to have some where we have to do the math manually, some of it, and you always want to make sure those match. So let's go do the probabilities now. Let's go look at our question. So it says choose one doctor at random. What is the likelihood or the probability that she is a pathologist? Okay, well, how many pathologists do we have?
Six.
6 pathologists. And how many doctors altogether? Let me go back to. So we're looking for the probability that we have. So the question was the probability of being a pathologist. You said 6 pathologists. That's right. Out of how many?
Out of how many? 6 pathologists out of 33.
Not, okay, that's the total number of MDs.
Oh,
But the total number of people
it's 38.
is 38, so use that. There will be times when we do use this column number or this column number. Those are conditional probabilities. Those are coming up in 4.3. But unless I tell you, make some other distinctions, I'm always talking about the whole sample. So if I'm looking for, in this case, I'm looking for A is the probability of selecting a pathologist, right? And that what that boils down to in terms of the basic probability formula is the number of pathologists over the total number of participants in the sample. So the number of pathologists we know was 6. That was self-evident from the chart. And then the total, that's why we had to go bother computing all those totals. This is 38 here.
Mhm.
Now we do our standard arithmetic routine.
Mhm.
So we have, let's change to the calculator screen. We have, let's do this. We have 6 out of 38. There's my fraction. If I want to reduce it, I go math, convert to frat. So there's my reduced fraction. It's 3/19. Okay, and if I want the decimal, I can either convert that to a decimal number by going to number 2, convert to decimal, which is 0.1579, or I could have just entered it again and divided. And then obviously, if I want a percentage, I just multiply this by 100.
Actually, on the answer key, it says 7/38.
Oops, did I miss
So
something? Possibly, let me see.
I think it's the total.
She is a pathologist, so. Oh, you know what? I missed one person. That's what I did. I made an
total.
error there. I'll show you why right now. I missed that. This is, there are, yeah, be careful here. Pathologists go, let me show you what happened. I fell for it too. Here's the pathologist row, right? These 6 people are MDs who are pathologists. But there's also this one, right? So the number of pathologists, the total number of pathologists is 7, isn't it?
Yes.
6 plus 1 is 7 pathologists. So it's 7 out of 38. Because even though they're osteopathic, they still study pathology. So there are 7 pathologists, not 6. That was my mistake. Let me fix that. So this is going to be, thank you for catching my error there. This is the number of pathologists, which is 7 out of 38. So this is going to be 7 out of 38, and that should match. Let's take a look. Let's do the math one more time here. So we get 7 out of 38. This one doesn't reduce because 7 is a prime number, and we get 0.1842, and that's 18.42%. 4211, just telling you that it's, so we have, this is, all right, let's go on to this.
It's
Oops.
zero. It's 1.84.
0 point. Oops. 0.1874, you said?
No, 0.184.
0.184. Okay. Like this?
Yes.
Okay. All right. Now let's
Seven.
go on to part B, which is, I think it asks us for another one of those ones where we have to exclude. He is an orthopedist or an MD. Okay, so let's find all the orthopedists. So that's 20 plus 2, right? So orthopedists or an MD, but we have some overlap there, don't we?
Mm-hmm.
All right, so let's see if we can figure this out. So here we have the orthopedists. So we'll do part B over here. This is the probability of being an orthopedist. Whoops. Oh, orthopedist. Orthopedist. Or MD, right? So now, there it is. So what's the probability of the orthopedist?
Five. Total of 5.
Okay, don't confuse the, hold on. Okay, screen share, get out of the way. And move this down. That's osteo. Okay, the orthopedists are in the 3rd row.
Oh.
So yeah, the osteo people are different.
So 22.
22 out of 38, right? So everybody here is going to be out of 38. We know that. So let me put, let's see. Annotations, where am I? I lost my annotated part of this. Where's my, here it is, okay. So we have 22 out of 38. Then how many MDs do we have?
7.
No. Okay, so this is where, yeah, this is where this gets, let me, hold on, because my screen share is acting weird. Let me see. Okay, much better. So now, oh yes, I know participants can see my whiteboard. All right, so here's my orthopedist. They're here. This is my orthopedist. So there's 22 of those. And my MDs are this column here, right?
Oh.
So I have 33 MDs. So I have 22 over 38.
Okay, because on the answer key, it's different. It says it's 35 over
Yeah,
38.
I'm not done yet. I'm not done yet.
Oh,
Because when I count my orthopedists, there's 22 of them, right? But you have to think, did I count somebody twice? Watch. So here's my orthopedist, right? And then I count my MDs here. So I count this group. You see?
mhm.
So I use this 22 and I use this 33, right? So I have plus 33 over 38. Now, did I count a group twice?
Yes.
How many were in that group that I counted?
2.
No. Look for the overlap. The 2 doesn't overlap anything. But I circled this 20. See this 20 here?
Mm-hmm.
I circled this 20 twice. These are my orthopedic MDs right here, this group. This group I counted twice. So now I have to take 20 off because I don't want to double count anybody. 20 over 38. Any questions about this part so far?
Not really.
No? Okay. Now, if you do the math, go ahead and do the math and see if you come up. You should get 35 now.
I
See if
did.
you get 35. Did you get that? And you know how to get the fraction and the decimal from here?
Yeah.
Okay, so I won't go over that and belabor it. Good enough?
Yep.
Okay. This comes out to 35 over 38. Okay. Now we go on to the next one. So you have to watch that overlapping. If you have an overlap, then you have to take off the people or the objects that are overlapping. All right. Okay, let's switch our screen share here and go back to the homework. That brings us to number, oops, wrong screen. That brings us to, I'm sharing the wrong one. Let me share this. Okay, there we go. Now we're bringing up number 5. At a convention center, there are 7 math instructors, 5 computer science instructors, 3 statistics instructors, and 4 science instructors. If an instructor is selected, find the probability of getting a science instructor or a math instructor. So there's 7 math, 7 math, and 5 computer science, and 3 stats, and 4 science. Now, I'm assuming for the sake of this example, I don't think they're counting statistics as mathematics. I think they're counting them separate. So it says find the probability of getting a science instructor or math. I'm assuming that these groups don't overlap, but we'll find out. Just from the way the question's written, that's what I think. But that they're not meant to overlap. But we do need to figure out how many total we have. So how many total instructors do we have?
19.
Okay. So we have 19 instructors. We want the probability of getting a science or a math instructor. So what are we going to have to do here?
Add the
Yeah.
science and math.
We have to add the science, which is
4.
4, and the math, which is 7,
7.
right? And 4 plus 7 is
11.
11, and we have a total of
19.
19. So with any good fortune, which I think, yeah, that's all that's what she wanted.
Mhm.
She was just looking for these to be excluded. Now, 6 is going to be a little bit of a trick because not because it's hard, but because you have to construct your own distribution from the information. That's what's hard about this. So I want you to see if you can, I'll put it on the screen. I want you to see if you can get a head start on it. In a statistics class, there are 18 juniors and 10 seniors. If 6 of the seniors are female and 12 of the juniors are male, 12 of the juniors are male. If a student is selected at random, find the probability of selecting the following. Before we can do this, we have to set up a distribution. You have to set it up first. Okay. So this is going to be a little bit of an issue. Let me see. Now, I'm going to look for my screenshot of this because I was doing it earlier. Okay, pictures. Here. Yeah. And I need my screenshot. Did I not? Oh, crud. But I might have a white. I don't think I saved. Yeah, that's all right. I'll do it again. I thought I took one, but I guess I didn't. So let me go to the whiteboard. So we have 18 juniors, 10 seniors. Okay, so let me. Here we have another, we're going to get another box. We have 18 junior. We have 10 seniors. And we have some information about them. We know that. Did I write this down somewhere? But not on that. Okay. This was one other. Okay. Let me go back. So I know that there are 6 of the seniors are female and 12 of the juniors are male. So 6 female seniors and 12 male juniors. Okay. So we're going to have this. We're going to get rid of that. We're gonna go to our share here. We're gonna get our little, okay, so we have from here, we have 18 juniors, and we know that 12 of those juniors, 12 juniors, male. And we know that 6 seniors are female. So we're going to draw our box. We're gonna have our regular 3 by 3 going on here. Now this is a little bit. So we're gonna have our juniors. Move him over there. We're gonna have seniors. And we're gonna have a total. And we're going to have male. And we're going to have female. And we're going to have a total here. Oops. Total. All right. So we have a total of 18 juniors. That means that I'm going to put my 18 here. I have 10 seniors. Means that I have a 10 here. Which then means I have 28 people. Okay. Now, of the juniors, so going to the juniors, 12 of them are male, 12 here. Notice I put the 12 where the males are. So how many female juniors do we have?
Male juniors is 12.
Right. How many female juniors? In other words, what goes
There is none.
in, huh?
There is none.
Well, it's not given to you, but if there's a total of 18, there are 18 juniors, right?
Oh wait, so 18 minus 12?
Right, would be how much?
6.
Very good. So that's what I mean. Sometimes you have to do a little extra work. 18 minus 12 is where we get 6 from. Okay. But that's kind of important to know that that's there. So now 6 seniors are female. So I have 6 seniors who are female. How many male seniors then do I have?
Six. So 6 minus 10. No, 10 minus 6.
10 minus 6, which is
4. There's 4 male seniors.
very good. So now 10 minus 6. Very nice. So now 10 minus 6 is 4. All right. Now let's add 12 plus 4. That's 16.
16.
And
6
6 plus
12.
6 is 12. And is 16 plus 12 28? Yes, it is. So we're More than likely on the right track. Okay, so we have our box now, right? Now we can get any probability they want. So let's look to see what probability they want us to get. I think we have a couple of questions to answer about this. Let's take a look at it. So whoops. There's the
A
homework.
junior or a female?
Yeah, a junior or a female. Now, ask yourself, are these overlapping categories, junior and female? They
Yes.
are, right? Because there are juniors who are female. So when you do this, you have to account for that overlapping category. Okay, junior or female. So now we're going to do this. We're going to say the probability of junior or female is equal to, and this time I'll write the formula out. The probability of junior plus the probability of female and if we need it, which we have an overlapping category, this is going to be female or junior and female, junior and female. So how many juniors do we have?
6 that are in female.
Okay, we have 6
Oh,
who are
18.
female. That's actually those. Okay, so let me point out something. These 6 juniors here are female. That's this group. That's junior and female. The total number of juniors we have is this. Here's my juniors. Here's my total, 18. So this is 18 plus how many total females do we have?
6.
No, the
Oh.
total number of females are
12.
12. And then the 6 that are both are my overlapping one. And we'll be out of 28.
28.
So what does that give us?
Um, 24 over 28.
Okay, good. And if you reduce it, you get?
If you reduce it by 4, you get 6
Over
7.
7. Very good. That's right. Which is correct. Good job. Now, how about let's do the next part. What is the next probability asking us to do? Let me get rid of that.
Next
Let's-
probability is a senior or a female.
Senior or female? Let me just finish this. This is 6/8, right? 7/8, I should say. No, 6/7.
Yes.
Bad arithmetic there. So 6/7. Now this is senior or female. What do you think we're gonna do here?
We're gonna do the same thing, but this time it's gonna start with 10.
Right. The seniors are 10, so this is probability of senior or female. It's going to be probability of senior, right? Plus the probability of female, right? Minus the probability of senior and female. All right,
Because they're overlapping again.
they are. Mhm. So what is my probability of senior?
10.
You said 10 out of 28, right? How about the
Mhm.
female part?
12.
That was 12, right? And how many do we remove?
Is it 6?
Well, we're looking for, let's see, we're looking for B, we're looking at senior or female. So we need to remove the intersection of senior and female. So here, that's find the seniors. There's the seniors. Find the females. So we're removing
6.
this one. Okay. I just wanted to make sure you were looking, because in this case, they happen to be the same number, but if you have to be looking in the right place. So yeah, you're removing 6. Very good. So here you're removing 6 people. And remember, this is all over how many?
16.
No. How many altogether?
Oh. 12 plus 10 plus 12 minus 6 equals 28.
20. Okay, so I think you answered. Okay, so the top of this is 22 minus 6, which is 16. That was correct. What I was actually asking you was how many altogether. There are 28, right? So
Yes. Totally.
the thing that I want to caution against, because I've seen people do this, you're doing pretty well, but just be careful that it's a fraction, okay? Because I've seen too many people lose the denominator on their answer. So this is over right now, this is over the total 28, okay? So your probability needs to be a fraction here. So this is 16/28, and we know how to reduce this, right? If you need help, by all means, use your calculator. That's one of the reasons it's there for you. 16/28. This is going to be,
They're both divisible by 4. So if we divide 4 on both sides, that means we get 4/7.
beautifully done. Good. You have one more part. Impress me. You have one more part to this question, Jason, and then we'll wrap it up for today, okay? What is the last part of the question say?
a junior or a senior.
Mhm. So part C, probability of a junior or a senior. So what are we gonna do with this?
That means P of the number of juniors,
Probability of being a junior plus,
the total number of seniors.
now in this case, do they overlap?
No, they don't.
No, so we don't need this last piece. Now, if you happen to put it in there and you put 0, that's okay, but you don't need the third piece this time because this is an example. Remember I told you we would get more examples. These are an example of mutually exclusive events. You can't be a junior and a senior at the same time. So what's the probability of being a junior here?
18.
18 out of 28. Right?
Mhm.
And the probability of being a senior is?
Is 10.
10 out of 28. So then
Which
if you add them up, you get what?
28 over 28.
Right. And that makes
Equals 9.
sense because you've included everybody in the sample, right? Everybody in the sample space. And so we get 1 or 100% if you want. This is one of those cases where we included everybody. Everybody gets to be in the party, right? And that's how it is. And
Okay.
that's how it's done. Very good. Very good.
Yep.
I think you're going to do a good job with that. We have more tutoring sessions tomorrow night. So feel free. And like I said, there'll be more. This will be up. This video will be up this afternoon. There's some help with another problem that I have that's coming up. So I've got about 3 videos that are going to be posting. So hopefully my internet connection will cooperate and we'll get those all posted for you before too long today. Okay. But you're
Alright.
off to a great start, Jason. Congratulations.
Thank you.
All right. We'll see you soon. Okay.
Alright, I'll see you tomorrow.
All righty. Bye.
Bye-bye.
Oh, Lord. Let me stop sharing.